Assalamu alaikum. Welcome to the 45th lecture of Software Quality Assurance. आज हम पिछले कुछ लेक्चर्स की करीबन 20-22 लेक्चर्स का रिव्यू करेंगे. So this would be a very fast-paced lecture in the sense that we will cover or review actually a lot of material that falls under different categories. आपको रिफ़्रेश कर दूं कि रिमाइंड करूं कि हमने सॉफ्टवेयर टेस्टिंग के ऊपर बड़ी डिटेल से बात की थी और लेक्चर्स नंबर 23 से लेक्चर नंबर 32 तक हमने सॉफ्टवेयर टेस्टिंग के मुख्तलिफ एस्पेक्ट्स को बहुत डिटेल से कवर किया था. तो सबसे पहले हम सॉफ्टवेयर टेस्टिंग के ऊपर कुछ बातें करते हैं. टेस्टिंग और सॉफ्टवेयर क्वालिटी एश्योरेंस का बड़ा पुराना और बड़ा इमोशनल कहना चाहिए अटैच्ड रिलेशनशिप है. इट इज़ वन ऑफ द मोस्ट इम्पॉर्टेंट पार्ट्स ऑफ क्वालिटी एश्योरेंस एंड एक्चुअली द मोस्ट परफॉर्म्ड QA activity. Testing has been a basic form of defect removal since the beginning of this profession, that is computer programming. And for majority of software projects, testing is the only form of defect removal which is utilized, although we have been trying to change that and introduce inspections and other defect prevention and defect removal techniques. The basic idea of testing involves the execution of software and the observation of its behavior or outcome. If a failure is observed, the execution record is analyzed to locate and fix the faults or errors or defects that caused that failure. And in that case, we say that our tests are successful, because using those tests we have been able to sort of crack the software and sort of been able to destruct the software. Otherwise, that is, if the software behaves correctly and according to specifications, then we gain some confidence that the software under testing is more likely to fulfill the designated functions that it is supposed to do. And so we can say that the dynamic execution of software and the comparison of results, that execution against a set of known predefined criteria, is known as software testing. Software testing primarily demonstrates quality or proper behavior of the software, and it is also used to detect and then ultimately fix problems. So we have multiple objectives regarding software testing. As you have been taught in this course and others also, and through your experience, you are, I'm sure, convinced that it is time that we leave ad hoc software testing behind and we start processing testing activity and we start conducting testing activity in an organized and planned fashion. So if you look at the software testing process, we find that it has three major activities. Number one is test planning and preparation. Number two is test execution and related activities that go with that execution. And finally, very important, is analysis and follow-up as a result of the first two major activities. If we break down the first activity, which is test planning and preparation, we can say that it consists of setting up of goals for testing. Number two, it includes selecting an overall testing strategy. Number 3, it involves preparation of specific test cases which will then be applied to the software. And finally, it involves preparation of a general test procedure that will be used to conduct the software testing activity. The second major activity, which is test execution, involves execution of software tests which were planned and prepared in the first activity that I just described to you. And it also involves observation and measurement of product behavior, which tests can be used in the third step in the analysis and follow-up activities. And the analysis and follow-up activity actually includes result checking and analysis to determine if a failure has been observed, and if so, follow-up activities are initiated and monitored to ensure removal of underlying causes of faults that led to the observed failure in the first place. Now, it is very important when we were talking about, I tried to highlight that point very discreetly and very clearly, and that is that if we compare software testing with inspections, which is another form of defect removal, we see that inspections are a direct way of finding defects. On the other hand, software testing is an indirect way where we try to observe the behavior on how software behaves when these tests are applied to them. And based on that observation, we can determine if the software failed or if the software passed. Now, if the software failed the test, that indicates that there is some cause which has resulted in the failure of the software test. Now, it is the responsibility of programmers to find what that cause is and remove that cause from the software. Now, the generic test process that I have just described to you is shown here in the picture. You have seen this picture before when we were discussing software testing in detail. To remind the students, it has 3 main activities: planning and preparation, execution of software tests, and analysis and follow-up. And this picture shows the relationship between these 3 activities, and it describes the testing process in a very nice way. Now, as I was saying before, we talked about planning and preparation, that software testing is and has been a part of the quality assurance activities for a long time. One of the things that we have learned in this course is that we need to eliminate as many defects from the software as possible before we release them to the customer. And we use different software testing techniques for this purpose. But one of the key things that we try to achieve is to improve the defect removal efficiency of the software product. To remind you of what defect removal efficiency is, that it includes how many defects percentage-wise were found or detected and corrected before the software product was released to the customer. And higher the defect removal efficiency, the higher the quality of that software product is considered. And so we use different testing techniques to improve this number, the defect removal efficiency. And studies have shown that if we use software testing and software inspections, this number can go up substantially. And so it is important to use the right testing technique in addition to software inspections or reviews to improve the defect removal efficiency of software product. Software testing are very effective in finding errors of commissions or things that are done wrong, as compared to finding errors of omission or things that are left out by accident, because it is very difficult to actually find things which are not, or to test things which are not present in the software product. But if something is incorrect, that can be detected fairly easily, and so software testing is very effective in that respect. And inspections are very effective in finding things which are not included in the on the work product that is being inspected or reviewed. Now, one of the things that I had said before is that if software test is able to result in the failure of the software, that is, as a result of execution of software test, the software product fails, then that is a successful software test. And that should be the objective of software testing. Software testing is a process of execution of a program with the intent of finding error. The intent is to detect errors and not the other way around. And so we need to develop good test cases which help us in achieving this objective. And a good test case is one that has a high probability of finding an as yet undiscovered error. And a successful test obviously would be the one that uncovers an as yet undiscovered error. So our achievement in conducting successful software testing is by trying to find as many defects and errors in the software program, which means that we have to ensure that our software shows or our software tests show the failures that I talked about a little bit earlier. So this objective imply a dramatic change in thinking, a dramatic change in viewpoint if we compare it to our programming mindset or programming viewpoint or design viewpoint. This software testing move counter to the commonly held view that a successful software test is one in which no errors are found. Our objective as professionals in software quality assurance and software testing is to design test cases that successfully and systematically uncover different classes of errors, and to do that with minimum amount of time and effort. And that's where your professionalism would come into play, and we need to utilize the resources available to us in efficient manner. Now, if software testing is conducted successfully, it will uncover errors in the software, and as a secondary benefit, testing demonstrates that software functions appear to be working according to the specification. These are the secondary benefits, because it is very easy to write if we don't focus on our primary benefit, primary objective, which is to find defects. We can also, as a result, get the confidence that behavioral and performance requirements appear to be met in the development or in that software product. And so the primary objective is to ensure that the software defects are removed from the software product by conducting or execution of software tests. Testing cannot show absence of errors and defects. It can show only that software errors and defects are present in any software. So this is a very different approach compared to programming or design, which are considered a constructive process, while software testing, on the other hand, is a psychologically destructive process in which we try to break down the software as much as possible. We also talked about the testing principles. Let's go through and review them once more. All tests should be traceable to customer requirements. And this is of primary importance because everything that we do in software engineering, in development of software products, is to focus on customers' requirements and then drive all our activities based on the customer's requirements. And so our testing activities should also be based on customer requirements. Number two, the tests should be planned long before testing begins, and this is one of the things that I had mentioned when I talked about the testing process today. And we had dealt with this concept in detail in one of the lectures earlier in the course. We also know that the Pareto principle, that is also known as the 80-20 rule, applies to software testing. Studies have shown that 80% of all defects found will likely be traced to 20% of all modules. These are typically known as error-prone modules, and they should be isolated and tested very thoroughly. And so you would be able to get the benefit of efficiently using your resources and your time. And so it is very important to look at the risk areas in software product where the technology is new, or where the domain is not very well understood, or where we have complex algorithmic information. And so these are the areas, these are the modules where would you want to concentrate as far as testing is concerned. And you will be able to find that this Pareto principle will help you and guide you in isolating these error-prone modules. The testing should begin in the small and progress towards testing in the large, which means that you should principally start with unit tests, small units, and then go towards integration and other. One of the things that we learned in this course, and I'm sure you realize the extent that exhaustive testing is not possible even in fairly small software products. And so you need to determine the minimum number of tests that your software product requires in order for it that all statements are executed and tested at least once. But the number of path permutations for even a moderately sized program is exceptionally large, so it becomes impossible to execute every combination of paths during testing. And this is a known fact, and if you try to, and if you wish to do exhaustive testing, you will not be able to do that. You won't be able to come even near that, and as a result your planning will fail. And so one of the things that you must remember while planning software testing is that you cannot plan to do exhaustive testing. Let's now talk about broad categories of testing. There are 3: general testing, specialized testing, and 3 is testing that involves users or clients. General forms of testing are concerned with almost any kinds of software and seek to eliminate common kinds of software defects such as branching errors, looping errors, incorrect outputs and the like, and this is common in all sorts of software. There's no, it's not a requirement for specialized software. The examples of general form of testing include unit testing, system testing of full application, new function testing, regression testing, and integration testing, and others can also be included. And you perform general form of testing in all kinds of software. But in some cases you do require special software testing. The focus is narrower here, and you seek specific kinds of errors, such as problems that only occur under full load, or problems that might slow down the performance of the software system. So you can imagine that this is not applicable in testing of all software products. This includes testing of for viral protection, for stress or capacity testing. It includes performance testing, security testing, platform testing. Y2K compliance testing was also part of this, and independent testing is also an example of specialized testing. And then there are other forms of testing which involve users and clients, aimed at finding usability problems and ensuring that all requirements have in fact been implemented related to the user interface. This includes customer acceptance testing, beta testing, usability testing, lab testing, and also the clean room statistical testing. One of the things that is very important in software testing is test case design. Any engineered product can be tested in one of two ways. Number one, knowing the specified function that a product has been designed to perform, and number two, knowing the internal workings of the product. And so based on this concept, software testing has two very important kinds of software testing. One is known as black box testing. The other is white box testing. The black box testing is also known as functional or behavioral testing, while the white box testing is also known as structural or glass box testing. When we were talking about software testing earlier in this course, we had devoted quite a bit of time, because of the importance and nature of these testing techniques, to both of them. To summarize what we had covered in the course and what you have read in the material, in the books, black box testing is aimed at finding functional, is aimed at checking the functionality of the software. The software engineers and testers who are assigned to perform black box testing do not have access to the code. They cannot look inside the software program, or as look inside the box. The purpose is to check interfaces and functionality of the software components and units. While on the other hand, the white box testing is usually performed by the programmers. They have access to the code, they know the internal logic, the data flow, the control flow, and they can design tests to check the internal workings of the software component, whether it's a small unit or a large unit. But it is very important that the test engineer has access to intricate inside details of algorithms and data structures to conduct white box testing. These are the two broad categories of software testing, and without having the we need to utilize both of these testing techniques in the successful software testing strategy. If we look at different approaches, testing approaches, the black box testing includes system testing of full application, it includes new function testing, it includes lab testing, it includes usability testing, customer acceptance testing, beta testing, and clean room statistical testing. Now if you look at this list, all of these testing approaches are geared to find and check the functionality of the software system of a software product, whether it relates to the functional requirements or to the non-functional requirements. And so when we are performing black box testing, we can only look and interface with the product from the outside of the software module or the outside of the software box, so to speak. And black box testing can only talk to the software system through the interfaces. And all the different approaches that I have mentioned to you include that concept. Now comparing that to white box testing approaches, the list includes subroutine testing, unit testing, viral protection testing, stress or capacity testing, performance testing, security testing, and Y2K testing. If you look at this list and the testing approaches, all these approaches require that the test designer has information about the data structures, about the control flow, about the data flow, and algorithms of the software which is being tested. And so white box testing is very effective if it is conducted by those people who are the developers of the software system. Here I would like to clarify one thing, and that is in certain cases, like in Y2K testing or spiral testing, spiral protection testing, for example. These two kinds of software testing are most effective if they are done by third party or specialized test designers and test professionals, because this is a very focused and narrow form of software testing. But even with that, they require access to software code, and without having complete access to the software that they are testing, they will not be able to conduct white box testing efficiently. Some of the testing approaches use both white box and black box and combine them. They include independent testing, regression testing, integration testing, and platform testing. And if you want to conduct any one of these testing, you are applying both white box testing techniques as well as black box testing techniques. Let us now for a minute focus on the comparison of black box and white box testing. Typically, it is the perspective which distinguishes black box testing from white box testing. This perspective is, do we have access to the inside detail of the software component or not? However, black box and white box testing can also be compared using other criteria, which includes the objects that are being tested, the timeline, the defect focus, defect detection and fixing, the techniques that fall under each of these, and then the testers who are going to perform software testing. As I said, that white box testing is most effective if it is performed by developers themselves, and black box testing is effective if it is not performed by the developers. Let us now discuss the white box testing techniques. We talked about basis path testing, we talked about condition testing, we talked about data flow testing, and we talked about loop testing in the white box. We also determined, when we were talking about white box testing, we talked about a very important concept, and that is the cyclomatic complexity. And this number helps us in determining the independent paths that are needed to test the entire coverage of the software system. Now, the black box testing attempts to find errors in categories like incorrect and missing functionality, interface errors, errors in data structures or external database access, behavior or performance errors, and initialization and termination errors. And for that, we do not need to know the intricate details of the software components. The black box testing techniques that we covered were equivalence partitioning and boundary value analysis. Another area that we talked about was testing strategies. For an effective software testing process, we need to have a strategy that includes combination of white box testing, black box testing, and also testing at different levels, like at unit level, at an integration level, and so forth. And so the characteristic of a good testing strategy includes, number one, that the testing begins at the component level and works outward towards the integration and entire computer-based system. And we have talked about this concept in testing principles also. The second point of testing strategy is that different testing techniques are appropriate at different points in time. You cannot apply white box testing where black box testing is appropriate, and vice versa. Number three, testing is conducted by the developer of the software for large projects or an independent test group. And number four, testing and debugging are different activities, but debugging must be accommodated in any test strategy. Any test strategy must have four things or three things in the minimum, and fourth, system testing is also necessary in some cases. So the three things are unit testing, integration testing, and validation testing. And system testing is also required in certain contracts, according to certain contracts. And we had a good discussion on these testing, these components of testing strategy. Let us now review the V model of software testing. So you're looking at the V model of software testing, where if you are going to check the coding errors, you do unit testing. The design errors will be found in integration testing, and requirements errors are found in the validation testing. So any testing strategy must have these four aspects of testing approaches. Number one, unit testing. Number two, integration testing. Number three, validation testing. Number four, system testing, which is applicable to mostly to government contracts. We also talked about debugging in this course. Debugging is the activity where software testing has resulted in the observation of a failure, and then it is the responsibility of the programmers, of one or more programmers, to take the causes, to look at the symptoms and to look at the failure and then determine the cause of the failure and remove that software defect. We also talked about automated software testing, and that how automated software testing can improve the productivity of software testing, and many menial and those tasks which are of repetitive nature can be automated, and the productivity of the software development life cycle improves substantially, and especially that of software testing. We also talked a little bit, actually we talked in detail about test planning. We talked about how a test plan is prepared and documented, and at this point there is no need to review that because that has been discussed in quite a bit of detail. Now, one of the things which is very important is to determine when to stop testing. Actually, you are never done testing. The burden simply shifts from the development organization to the customer, and typically there is no definitive answer. However, you can, on a small scale, you can ask a question when to stop testing for a specific test activity, and on a global scale we can ask a question when to stop all major test activities, because the testing phase is usually the last major development phase before the product is released to the customer. This question is equivalent to when to stop testing and release the product to the customer so that they can utilize it, they can use it and apply it for their economic benefits. There can be two answers to this. One is resource-based criteria. Use resource-based criteria where the decision is made on the consumption of resources. The most commonly used criteria are: number one, stop when you run out of time, or stop when you run out of money for conducting software testing. However, even on a cursory observation, you can determine that such criteria are irresponsible as far as product quality is concerned, although they may be employed if product schedule or cost are the dominant factors or dominant concerns of the product in question. You can also use or apply the activity-based criteria, commonly in the form of stop testing, when you complete planned testing activities. So anything and everything that you have planned for in the test planning phase or activities, if all these activities are completed, then you can assume, and you can safely assume, that all the testing core have been completed. This criterion implicitly assumes that the effectiveness of test activities in ensuring the quality of software product. However, this assumption could be questionable without historical evidence based on actual data from the project, from the concerned project. So this is always a challenge for project managers to decide when to stop testing and release the product to the customer. Now, this was a rather brief overview of the 9 or 10 lectures that we had on software testing. After that, we had lectures on software configuration management and its role in quality assurance. We talked about configuration management and SQA from lectures 33 to 37, and the primary concern and the primary focus of software configuration management is that change is inevitable when software is built, and changes will happen in all work products and during all processes in software development lifecycle. Now, what happens is that change increases the level of confusion among software engineers who are working on a project, and confusion causes lots of problems. Confusions happen, or confusions arise, when changes are not analyzed before they are made, they are not recorded before they are implemented, changes are not reported to those who need to know, and are not controlled in a manner that will improve quality and reduce errors. We need to minimize this confusion, or else our projects will get out of control. Software configuration management helps us in minimizing this confusion. This is an umbrella activity and is applied throughout the software development process. Let's look at the purpose of SCM activities, which include identify change, number 2, control change, number 3, ensure that change is being properly implemented, and number 4, report changes to others who may be interested in that. Now, it is important to realize that most of the changes that are requested in software are justified, because managers want to utilize their resources in the best possible way. The customers want to have better understanding as part of the software development activity of their needs, and the technical staff wants to use the best tools. So many of the changes, actually most of the changes in software development process are justified, and so we need to manage this properly. Software configuration management is usually has 2 aspects. One is the process related, and which is managed by the change control board or change control authority, which has the final word on approving a certain change request. Since we are talking about software, we would say engineering change request. And the other part is the tools related part, because usually software products have many components in them, and if you talk about an object-oriented software project, then it has many classes in them, and so we need to properly manage and control the evolution of these software artifacts. And so typically an organization would use a process which is controlled by the change control authority or change control board, and use one of the tools. There are a number of software configuration management tools available in the market. Some of them are free, especially open source tools, and the others are commercial tools which are acquired by paying the license fee to the developer of those tools. So any SCM organization must have both a process which is headed by or controlled by a change control authority, and the other part is the tool. Without both of them, SCM functions or SCM activities cannot be properly executed. After that, we talked about the software configuration management plan and also the software quality assurance plan in quite a bit of detail. We looked at the different sections proposed in the IEEE standards for both of these very important plan, SCM plan and SQA plan. After our discussion ended on software configuration management, we discussed process-related activities. We talked about process assurance, we talked about process improvement. Process assurance consists of the collective activities carried out while developing a product to ensure that the methods and techniques used are integrated, consistent, and correctly applied. Emphasis is given to cost, time, technical requirements, testing, measurements, and prototyping. And so process assurance is a very critical, tightly coupled concept with respect to quality assurance. Process assurance involves the relationship of several different components. Depending on how these are managed, they can have a major positive impact on the product's quality. Once an effective process assurance program is put in place and shown to be beneficial, then emphasis can be placed in making verification and validation strategies effective and in improving the quality of the software product, which is actually the goal of the software industry. Successful software process assurance is based on planning and organization, and we talked in detail about what are different aspects of planning and organization with respect to process assurance are. And following that lecture, we talked about capability maturity model, and we talked about capability maturity model integration, or CMMI. CMM and CMMI are two process improvement models that have been proposed by Software Engineering Institute. The popularity of CMM resulted in the development of several models, mostly in system engineering areas, and after a while it was becoming difficult to integrate all of these models together, and so another model, CMMI, or capability maturity model integration, was started, which combines all of these models into one and is applicable to not only software but also system engineering in services and acquisitions and so forth. But to summarize what the CMM and after that CMMI have done to the improvement of software industry, I would just like to say that the quality of software products have improved substantially after the CMMI. CMM was proposed. The process has improved substantially. Basically these two models and others like them are collection of best practices in the software industry. The next 3 lectures after CMMI were focused on an introduction to quality metrics. We can divide metrics into 3 categories: product metrics, process metrics, and project metrics. The first 2, that is the product metrics and process metrics, are the most important as far as quality metrics are concerned. And actually, quality metrics are a subset of these 2 categories of metrics. The project metrics also have impact, but are not as directly associated with quality metrics as the other 2. And we spent 3 lectures on discussing these very important topics. We also, in the last lecture, talked about and discussed a process model for software quality assurance and quality engineering. And so this brings to the end this lecture and actually this course. In this lecture we have talked about the last 2022 lectures, and I gave you an overview of what we had covered in these lectures. So I wish you best of luck in your education and in your professional career. It has been nice teaching you this course, and I am sure that you have learned quite a bit about quality assurance through this course. Thank you very much.